In 1966, a restaurant cook at Disneyland swept stale tortillas off his kitchen floor, tossed them in a deep fryer, and dusted them with a spice blend costing less than a penny per serving. That accident is now a brand worth $5.4 billion a year. But here's the crazy part. The single most valuable ingredient in a bag of Doritos isn't the corn. It's not the cheese. It's a powder so precisely engineered that Frito-Lay's own food scientists call it the most neurologically optimized flavor profile in snack history, a dust that overrides your brain's natural stop-eating signal. Today, we step inside the Frito-Lay factory to break down how corn becomes a perfect triangle at 5,000 chips per minute, why the seasoning uses technology borrowed from the pharmaceutical industry, and how a single bag of Doritos contains more engineering than most smartphones. The engineering question. Think about the last Dorito you ate, that triangle geometrically identical to the one before it, that crunch, the same snap across every chip on Earth, and that orange dust refusing to leave your fingers with the same intensity on chip number 1 and chip number 400 million. 3 engineering problems took Frito-Lay decades to solve: shape, texture, and the dust itself. How do you take wet corn dough and make a mathematically consistent triangle, guarantee a perfect crunch at scale, and make a powder stick to an oily surface with zero variation? None of these problems existed when Doritos began, because Doritos didn't begin in a laboratory. They began in a trash can. The trash can that built an empire. Anaheim, California, 1964. A Mexican restaurant called Casa de Fritos operates inside Disneyland. At the end of every shift, kitchen staff throws away stale tortillas, too hard to serve, headed for the dumpster. A cook whose name has been lost to history looks at that waste and sees something different. He cuts the tortillas into triangles, fries them golden and crisp, then tosses them in salt, chili powder, and cumin. Nothing complicated, nothing expensive. The chips land on the counter as a free snack. Customers start asking for bags to take home. Word spreads, and within weeks, Frito-Lay's marketing vice president, Archibald Clark West, visits Disneyland on vacation, eats at Casa de Fritos, and sees what the cook didn't: a national product. West returns to Frito-Lay headquarters and negotiates a deal. Frito-Lay buys the concept, though not from Disneyland and not from the anonymous cook, and industrializes it. He even invents the name, combining the Spanish oro, meaning gold, with Frito's own suffix, ito, adding a D at the front. Doritos, little pieces of gold. 5,000 perfect triangles per minute. A single Frito-Lay factory processes 42 million pounds of corn every year, roughly the weight of 12,000 cars, through nixtamalization, a process the Aztecs invented that hasn't fundamentally changed in 3,000 years. Cooking corn kernels in water and food-grade lime at roughly 200 degrees Fahrenheit. The alkaline solution breaks down the tough outer hull and releases niacin bound inside the kernel. Without this step, eating untreated corn causes pellagra, a disease leading to dementia, skin lesions, and eventually death. The same reaction that kept Aztec civilization alive is step 1 in producing a $5 billion snack food. The cooked corn is washed, drained, ground into masa, and pressed by heavy rollers into a sheet 0.8 millimeters thick, a tolerance of 0.05 millimeters, since too thick turns chewy and too thin shatters in the bag. Rotary die cutters punch triangles through the sheet at 5,000 chips per minute, per line, but roughly 25% of that sheet, the webbing between triangles, isn't a chip. It's scrap, recycled back into masa rather than wasted. Approximately 1 in every 4 Doritos you've ever eaten was a Dorito that failed its first attempt at becoming a chip. If you're finding this level of detail interesting, hit subscribe now. 350 degrees, 11 seconds, and a secret oil. The raw triangles enter a 40-foot fryer at 350 degrees Fahrenheit for approximately 11 seconds, as moisture drops from nearly 50% to below 2%, and water inside the mesa flashes into steam, creating thousands of microscopic air pockets. Those pockets are the crunch. When you bite a Dorito and hear that snap, you're hearing steam channels collapse. 11 seconds too short and the chip is soggy. Too long and it's burnt. The timing is locked into conveyor speed, verified by moisture sensors, logged every 15 seconds. The fryer oil is where the secrecy deepens. Frito-Lay uses a proprietary blend of corn, sunflower, and canola oil in a ratio that's a trade secret no single supplier knows in full, mixed to specifications existing in only 3 locations across PepsiCo, which acquired Frito-Lay in 1965, 1 year before Doritos went national. The oil that fries your Dorito is protected by the same corporate security as the Coca-Cola formula for a corn chip. The dust, a pharmaceutical-grade delivery system. The chips leave the fryer golden, crisp, and unflavored, still hot from the fry, critical for the seasoning drum, a rotating cylinder 10 feet across, turning at roughly 20 revolutions per minute. Inside, 2 things happen at once. A fine mist of vegetable oil sprays onto the chips, not for flavor, but as an adhesive layer for the seasoning to grip. Then powdered seasoning, a blend of roughly 30 ingredients, drops from overhead dispensers into the tumbling chips, a 2-stage system adapted from pharmaceutical tablet coating technology. The same process applying a precise drug dosage to a pill applies nacho cheese dust to a tortilla chip. The seasoning formula reads like a neuroscience experiment. MSG triggers your umami receptors directly. Disodium, inosinate, and guanylate amplify that signal, making the cheese taste more like cheese than actual cheese. Citric and lactic acids stimulate salivation, dissolving more seasoning and triggering more flavor receptors, a self-reinforcing feedback loop. Maltodextrin adds sweetness that never registers as sweet. Powdered cheddar, buttermilk solids, whey protein, and tomato powder round out the base. The target is 11% seasoning by weight, every chip, every bag, every factory, a tolerance rivaling precision manufacturing in far more serious industries. Why the bag is half empty. The final stop is packaging. Chips slide into a bagging station and are immediately flushed with nitrogen gas before heat sealing, not air, since oxygen causes fats to oxidize into rancid chips and moisture to absorb into soggy ones. Then most pharmaceutical companies know about their generic drugs. Drop a comment. Which snack has the most addictive dust? Doritos, Cheetos, or Takis? I'll pin the best answer. A bag left open overnight loses its crunch by absorbing water from the air, not by drying out. Nitrogen is inert, the same gas used in aircraft tires and Formula One fuel systems. It prevents oxidation and moisture absorption and cushions the chips during shipping. That air everyone complains about is a shipping airbag. A bag filled entirely with chips would arrive as crumbs. The roughly 60% nitrogen to 40% chip ratio is the result of decades of logistics optimization. Too little gas and chips shatter in transit. Too much and you're wasting fuel shipping empty volume. 60-40, engineered as precisely as the chip itself. 5,000 chips per minute. 11 seconds in the fryer. 11% seasoning by weight. A dust borrowing its delivery technology from pharmaceuticals. Packaging filled with the same gas used in Formula One cars. And it all started in a theme park kitchen with a cook who looked at garbage and saw gold. Next time on MadeMass, a product that took years to perfect. An ingredient list so strange food scientists are still debating it. And the factory secret that makes it impossible to replicate at home. Because behind every product you use every day, there's an engineering story no one's ever told you. Subscribe so you don't miss it.